Hi friends, welcome to the lecture of linear algebra. Now, today we are going to study the new concept in linear algebra, which is the annihilator of a set. Now, we have to see what is an annihilator. Let V be a vector space over the field F, the field F, and S is a substrate of V, then the annihilator of set S is the set of all linear functionals on vector space V such that f of alpha is equal to 0 for each alpha belonging to set yes, and which is nothing but the annihilator of a set yes. That is, if V be any vector space over the field F and S is a subset of vector space of V, then the annihilator of set S contains all those linear functionals on vector space V. That is, all those linear functions belonging to V star, such that f of alpha is equal to 0 for each alpha belonging to set S, and the annihilator of S is denoted by the annihilator of set S is denoted by is denoted by A of S, that is annihilator of S, or S to the power O, that is S annihilator. Thus, symbolically, A of S, that is S annihilator, contains all those linear functionals, that is linear functionals, these are the members of V star. So, annihilator of S contains all those linear functionals belonging to V star such that f of alpha equal to 0 for each alpha belonging to set S, and which is nothing but the annihilator of a set S. So annihilator of set S is nothing but which contains all those linear functionals belonging to vector space V star such that f of alpha has a 0 value. That is, each vector in V can be mapped onto a 0 scalar for each alpha belonging to S. Okay, and which is the annihilator of a set S. Now there are some important notes on this annihilator. Note first one. If S is equal to singleton 0, then annihilator of S is equal to whole vector space vista. Here we have to check if S is equal to 0, then the annihilator of set S contains all the linear functionals in V star. Since we know that every linear functional, if there is a linear functional, then it is a linear transformation, and every linear transformation maps a zero vector to a 0 scalar. That is, image of 0 is always a 0 only. Then each linear functional is a linear transformation. Therefore, each linear functional maps a 0 vector to a 0 scalar, and hence, and annihilator of S contains all those elements which belonging to V star such that f of alpha will be equal to 0 for each alpha belonging to S, as there is only one alpha which is a 0, and each linear functional in V star is mapped onto a 0 vector to 0 scalar. Therefore, annihilator of S is a V star. Okay. Now, second one is if S equal to V, then annihilator of S is equal to singleton V. If suppose S is equal to vector space V, then we have to prove that annihilator of S is equal to singleton 0. Again, we know that if f of we know that if f of alpha, there is one theorem, if V over F is an n-dimensional vector, sorry, V be an finite dimensional vector space over the field F, and if f of alpha is equal to 0 for all F belonging to V star, then alpha must be equal to 0. As here S equal to V, S equal to V means it contains all the elements of a vector space V, and we have to find out the S annihilator. It means S annihilator contains all those functions F belonging to V star such that f of alpha equal to 0 for each alpha belonging to S, and we know that 0 functional is the only functional which maps every vector to a 0 scalar, and hence S annihilator will be equal to singleton 0. Now third one, if V over here is a finite dimensional vector space, is a finite dimensional vector space, and S contains a non-zero vector, then S annihilator is not equal to this star. Here we have to prove that if V over F is a finite dimensional vector space and a set S contains one non-zero vector, then annihilator of S is not equal to V star. Let alpha not equal to 0 be any member of a set S. Okay. Now again we know that if V be a finite dimensional vector space over the field F and alpha be any non-zero element in V, then there exists a linear functional F on V such that f of alpha is not equal to 0. Therefore, by theorem, there exists a linear functional F on V. Linear functional F on vector space V such that f of alpha is not equal to 0. Of alpha is not equal to 0. As this one is the linear functional, therefore it is a member of V star. So here we get one linear functional which is not equal to 0, and annihilator of S contains all those linear functions whose value is always 0 for each alpha belonging to S. So as here one alpha which is not equal to 0 belonging to S, then there exists some linear functional which is not equal to 0 for that particular alpha. Therefore this S annihilator is not equal to V star, since here we get one particular F for which f of alpha is not equal to 0. Hence annihilator of S is not equal to V star, which implies annihilator of S is not equal to V star, and hence the proof. Okay. Now let S is any subset of a vector space V, then annihilator of S is a subspace of vector space V star. Now, if we have given one set S, which is a subset of a vector space V, then we have to prove that annihilator of that particular set S is a subspace of V star. That is, here given that S is a subset of a vector space V, and to prove that annihilator of set S is a subspace of V, and we know that any set W, any subset W of a vector space V is stated to be a subspace of that particular vector space V if it is closed under vector addition and scalar multiplication. That is, it is itself a vector space under the binary operation defined on that given vector space. Now, so it is sufficient to prove that it is sufficient to prove that yes, annihilator is closed with respect to vector addition and scalar multiplication. The addition and scalar multiplication. Okay. Now let f1 comma f2 be any two elements of yes annihilator. Be any two vectors as let us define first what is annihilator of S. Annihilator of set S is nothing but which contains all f belonging to V star such that f of alpha is equal to 0 for all alpha in set S. Now let us consider f1 f2 belonging to S annihilator B any two vectors as f1 and f2 belonging to S annihilator, which implies f1 of alpha equal to 0 and f2 of alpha equal to 0 whenever for all alpha belonging to set S. Since f1 and f2 are belonging to S annihilator, they need to hold this property. Therefore, this is from definition of S annihilator. Definition of S annihilator. Now first consider let C belonging to F be any scalar and alpha belonging to set S be any vector since S is a subset of V. Okay, now consider CF1 plus F2 of alpha is equal to CF1 of alpha plus F2 of alpha. Since we know that F1 and F2 are linear functions, As F1 and F2 are linear functions, then we can write CF1 plus F2 of alpha as a CF1 of alpha plus F2 of alpha. Or the other reason is by definition of addition in annihilator of yes, and which is nothing but C into F1 of alpha plus F2 of alpha. But we know that F1 of alpha is equal to 0 for each alpha belonging to S, and F2 of alpha will be equal to 0 for all alpha belonging to S. As alpha is belonging to S, then this value of F1 of alpha plus F1 alpha is equal to 0 and F2 of alpha will be equal to 0. C into 0 plus 0 for all alpha belonging to set yes, which is equal to 0, which implies CF1 plus F2 of alpha is equal to 0 for all alpha belonging to S. Then by definition of annihilator, CF1 plus F2 is belonging to annihilator of set S, which implies CF1 plus F2 belonging to annihilator of S. That is we have to prove. That is that is annihilator of S is closed with respect to addition and scalar multiplication. That is annihilator of S is itself a subspace by this property. So which implies S annihilator is a subspace of V star and hence the proof. Okay. Now next one is next there is one important theorem. Let V be a finite dimensional vector space. Finite dimensional vector space over the field F, and W is a subspace of V. W is a subspace of vector space V. Then dimension of W plus dimension of W annihilator is equal to dimension of vector space. So here, if V be any finite dimensional vector space over the field F and W is any subspace of a vector space V, then we have to show that dimension of W plus dimension of W annihilator will be equal to dimension of V. Now, prove given that V over F is a finite dimensional vector space and WB subspace of V. WB subspace of V. Now and to prove that, here we have to show that dimension of W plus dimension of W annihilator is equal to dimension of a vector space V. Okay. Now, as W is a subspace of vector space V, then there are some possibilities for W. Either W is a zero subspace of V, that is W equal to 0, and which is a zero subspace of V. Either W will be equal to V, or W is a, these are the two improper subspaces. And another possibility is W is any proper subspace of a V, that is dimension of W is not equal to dimension of V. Then there are two possibilities for this subspace W. So first one, case 1, let W be a zero subspace, that is W equal to singleton 0. As W equal to 0, now we have to show that dimension of W plus dimension of W annihilator will be equal to dimension of a vector space V. Then W annihilator is equal to all F belonging to dual space V star such that F of alpha is equal to 0 for each alpha is belonging to the subspace W. Since here we have find out the annihilator of W, but which is nothing but which contains all F belonging to V star such that F of alpha, as there is only one alpha belonging to W, which is a 0, that is F of 0 is equal to 0 since W is equal to singleton 0. And we know that every linear functional maps a 0 vector to a 0 scalar. Therefore, all F belonging to V star holds F of 0 will be equal to 0. That is, every linear functional maps a 0 vector to a 0 scalar. Therefore, W annihilator is nothing but V star. That is, every linear functional in V star holds this property, which implies annihilator of W is equal to V star. And we know that as annihilator of W is equal to V star, then dimension of W annihilator is equal to dimension of V star. Therefore, which implies dimension of W annihilator is equal to dimension of V star, since annihilator of W is equal to dimension of V star, that is dimension of W annihilator is equal to dimension of a vector space V star. Okay, as here W equal to singleton 0, that is W contains only a 0 element only. Then dimension of W is a 0 since there is no linearly independent element belonging to W, which implies dimension of W is equal to 0, which implies, consider dimension of W plus dimension of W annihilator is equal to dimension of W is 0 plus dimension of W annihilator is dimension of V star. Dimension of V star. And we know that dimension of a vector space and dimension of its dual space must be equal. That is, dimension of V star is equal to, if dimension of vector space V will be equal to n, then dimension of V star is also n. Therefore, dimension of V star is nothing but the dimension of vector space V, which implies dimension of W plus dimension of W annihilator is equal to dimension of vector space V. Therefore, the result holds for W equal to singleton 0. Thus, the result holds. Okay, there is no problem with W equal to a 0 subspace. Now we have to prove second case, that is W equal to whole vector space V. Case 2, W equal to vector space V. Now, as W equal to V, the annihilator of W contains all F belonging to V star such that F of alpha is equal to 0 for each alpha belonging to W. That is, which is nothing but F belonging to V star such that F of alpha equal to 0 for each alpha. As alpha, sorry, W is nothing but V for all alpha belonging to V. Again, we know that there is only one functional which maps every non-zero vector to a zero scalar, and which is the zero functional only. Hence, W annihilator is equal to singleton 0. Since we know that zero functional is the only functional, zero functional is the only functional which maps every vector, that is whether it is 0 or non zero, every vector to a zero scalar, and hence the annihilator of W contains only a single element which is a zero element, that is zero functional, which implies, as the annihilator of W equal to singleton 0, that is zero functional, which implies dimension of W annihilator is equal to 0. And as given that as W equal to V, which implies dimension of W is equal to dimension of a vector space V. Now consider dimension of W plus dimension of W annihilator is equal to, dimension of W is dimension of V and dimension of W annihilator is 0. So from this we conclude that dimension of W is equal, plus dimension of W annihilator is equal to dimension of a vector space and hence the required result. That is, from this conclude that the result holds for W equal to, thus the result holds for second case also. Now it remains to prove the result also holds for any proper subspace of a vector space V. Consider case third. Case third. Let W be any proper subspace of a vector space. As it is a proper subspace, then dimension of V is greater than the dimension of W. So let dimension of V is equal to some n, dimension of W will be equal to some. Okay. As dimension of V equal to n, dimension of W will be equal to m, and W is a proper subspace of V, which implies dimension of W is less than dimension of V, and dimension is always greater than 0. Possible that the dimension of a vector space V is 0, but here we consider the dimension of a vector space V is some finite dimension, which implies then from this conclude that 0 is less than m and which is less than n. Since here we consider that it is a proper subspace. Okay. Now